Hello everyone, I'm Teck. My PhD research interest is smart city applications in land use and transport. All of us have experienced smart city outcomes in some domains. To name a few: public transport as traffic probes, smart ticketing, smart parking, smart motorway and coordinated signals, Google Maps. The common themes in these smart city initiatives are Internet of Things and big data analytics. The IoT generates huge dataset that must be processed and analyzed to implement smart city services. About half of the global population is living in urban today. This is projected to reach 2/3 by 2050. That is 6.7 billion persons. Environmental, economics, and social sustainability is a must to keep pace with this rapid expansion. Smart city applications are vital to success and meeting sustainable developments. On personal level, smart city application change the way I travel. For example, if I have two options to travel from home to work, sensors and analytics work together to help me choose the quickest route. In my research, I adopt the following working definition of smart city. A smart city leverages technology and effective integration of city ecosystems with the objective of improving quality of life, boosting economic competitiveness, and enhancing accessibility and inclusivity. A smart city provides self-sufficient outcomes supporting the three pillars of sustainability through data-driven decision-making. In short, a smart city is built on technology, focused on improving sustainability outcomes. Up until now, smart city projects have mostly been pilots, but as the field matures, it's time to evaluate those projects with an understanding of how the benefits scale from the project level up to the metropolitan or larger scales. Recent research focuses on ranking smart city models, comparing a city's smartness with other cities, or evaluating a city's smartness maturity. A research gap exists in understanding how much value a smart city application generates for a city, and how those benefits could be predicted. My research aims to understand the heterogeneous benefits of smart city applications, and how those benefits could be predicted to better choose projects for the future. The research will combine empirical evidence of existing applications with information theory to answer the above questions. Information theory studies the transmission, processing, extraction, and utilization of information. It has application in information retrieval, intelligence gathering, gambling, musical composition, and etc. A key concept in information theory is entropy. Entropy quantifies the uncertainty in the value of a random variable or the outcome of a random process. The theory also provides methodologies to separate real information from noise and to determine channel capacity required for optimum transmission condition on the transmission rate. I am currently using the GTFSR bus dataset from Transport for New South Wales to understand the impact of transit lanes on on-time performance. In this context, the GTFSR dataset is generated by sensors installed on buses, which provide locations of each bus. The deployment of GPS in the transit fleet is an example of first-generation smart city application. GTFSR, as smart city application, brings to transport planning and management by allowing us to estimate the value of delay savings from bus lane and transit lane. This allows us to quantify inputs to decision about whether to build more transit lanes. I expect to find that smart city projects provide information that improve planning decisions and operations practices that reduce waste in the form of latent demand, unused capacity, and delayed operations. After demonstrating my approach on an established smart city application, I will undertake 3 to 5 data analyses to explore the benefits of smart cities projects. Each analysis will cover the performance of a specific smart city application. The research outcome of my thesis is to frame the collective results as evidence in support of a theoretical understanding of the value of smart cities generated information in transport decision making. Other datasets I'm considering at this stage are smart parking dataset. This allows to quantify inputs to decision about number of parking spaces provisions and optimize the resource utilization. Smart lighting dataset. This allows to quantify the energy saving, security, and safety benefits on streets, footpaths, and cycling and parks. Thank you everyone for your time, and I welcome your feedback in the Q&A or at the email listed here.